calculations. So we want to get the specific heat capacity of the metal block. So before we engage the formula, we also need to know what is the mass of this water. So one of the calculations that we need to take is the mass of water. What is the mass of water? We have not calculated the mass of water. We only have the mass of the calorimeter with the stirrer, then the mass of the calorimeter with the stirrer and water. So from this we can be able to get the mass of water by taking the mass of the calorimeter with the stirrer and water minus the mass of the calorimeter with the stirrer alone. So we are going to have the mass of water as this, ms, minus the mass of the calorimeter with the stirrer, which is mc. So that is what we have for the mass of water. Now, in this experiment, assuming that the heat loss is negligible, so note that NB, assuming then it will mean the following. So here we are assuming, because we are using the calorimeter to minimize the heat loss to the surrounding, in our calculations, the assumption is that there is negligible heat loss. When we talk of negligible heat loss, then it means that we don't have to put it into consideration. So we assume that the heat loss is negligible, and therefore note the following. So if our heat loss is negligible, then it will mean the following. It will mean that heat that is lost by the metal block will be gained by the water, and it will also be gained by the calorimeter. So we are going to say therefore that heat lost by the metal block will be equal to heat gained by the water. That is one. What else is gaining heat in this experiment? We also have our calorimeter, which is also gaining heat. But as we have seen, the calorimeter now will be able to minimize now heat loss to the surrounding. So we are going to say that heat lost by the metal block is equal to heat gained by water plus heat gained by calorimeter. Heat lost by the metal block will be equal to heat gained by water plus the heat gained by the calorimeter. Make note of that. When you have a hot spoon, a very hot spoon, you transfer it into a basin full of cold water. This spoon is losing heat. And what is gaining heat? We have the water gaining heat, and also your basin will also gain some heat. So that's what we are talking about here. And therefore, heat lost by the metal block, remember the formula for calculating the amount of heat from the specific heat capacity. We say specific heat capacity is quantity of heat all over mass multiplied by change in temperature. And therefore, quantity of heat is mass times specific heat capacity times change in temperature. So in our calculation for heat lost by the metal block, heat lost by the metal block will be given by the mass of the metal block, which is mB, multiplied by the specific heat capacity of the metal block, which is in question, specific heat capacity of the block, multiplied by the change in temperature. So what is our change in temperature for the metal block? The initial temperature of the metal block is this one. And the final temperature for the content is this one. So what is the change in temperature? Remember, this metal block is at a higher temperature than this final temperature. So we are going to have TB minus TF. So we have the change in temperature as TB minus TF. So that's what we have on that side, is equal to heat gained by water. Again, the formula, mass of water, and the mass of water we said is ms minus mc. We can therefore say that which is equal to mass of water, mw. So we are going to take here the mass of water times the specific heat capacity of water, which should be given in this question, multiplied by the change in temperature. The initial temperature of water is here, and the final temperature is here. And you can see, since we are transferring a hot block in the water, then it means that this temperature is higher than the initial. So we'll take TF minus TW. So the change in temperature is TF minus TW. Finally, plus heat gained by the calorimeter. Again, heat gained will be given by mass of the calorimeter. There is somewhere where we have the mass of the calorimeter with the star. They are together. So we have mass of the calorimeter times the specific heat capacity of the calorimeter, which should be given. So times the specific heat capacity of the calorimeter times the change in temperature. And the temperature is changing from TW to TF. And we have seen TF is greater than TW. So the change will again be like this one, which is TF minus TW. Sorry for this. TF minus TW. And this is what we are going to have as our equation. And from this equation, it is clear that now we can be able to get the specific heat capacity of the metal block, because in this we have MB, specific heat capacity. So that's what we have. So when we want to get the specific heat capacity of the metal block, you simply come and divide both sides by MB TB minus TF. And this other side again by MB TB minus TF. And when this cancels, we'll have this and that cancels, and therefore the specific heat capacity of the metal block will be given by this plus the mass of the calorimeter, specific heat capacity, times the change in temperature, all divided by the mass of the block multiplied by the change in temperature of the block. And all these letters are representing numbers, because in the question now we'll be given the mass of the block, we are given the temperature of the block, we are given the final steady temperature. So we'll be able now to substitute with values. So that's an experiment to explain how we can get the specific heat capacity of a substance. And in our case here, we are taking the substance to be a metal block. It must not only be for solids. We can also use it for liquids, as I was explaining with the T. So we can also use it for liquids, but we'll see this more in our numerical calculations. So we are saying that in determination of the specific heat capacity of substances, liquids and solids, we use a calorimeter to minimize heat loss to the surrounding. We have seen that it is highly polished. It has a lint which is a poor conductor of heat, and we have also seen that it is heavily lagged. Then we have been able to look at the measurements that we can take to be able to calculate the specific heat capacity. Then those are the measurements, the calculations. In an exam, you can be told to state some of the measurements that need to be taken, for example, in such an experiment, to determine the specific heat capacity of this metal block. And we have been able to see that we are saying that assuming that there is no heat lost to the surrounding, then it means that all the heat that is lost by the metal block will be gained by water and also by the calorimeter. And therefore, during our other lesson, we'll now get into calculations and we'll see how simple it is to apply all that we have learned in our experiment. So we'll be able now to calculate when now we have the numbers. So follow also in our next lesson as we do the calculations.